Good morning. This is question 1 for the review for the final for Math 170. This is a writing enriched question, and so when we do this, we need to make sure that we use complete sentences. And our question says to sketch the graph of the function f of x is equal to the quantity of x plus 4 squared plus 1 using the techniques of shifting, compressing, stretching, and or reflecting. To start with the graph of the basic function and show all the stages, use complete sentences, describe each transformation and how it affects the graph at each stage. Okay, so we know that we're going to be graphing. We're going to use the techniques of shifting and compressing, stretching, or reflecting, and that we're going to be writing some sentences. Okay, so if we're using the techniques of shifting, compressing, stretching, and reflecting, and we have this function, that means that we're going to be thinking about the vertex form of a function, which is y is equal to x minus h x minus h squared plus k, where h and k are the vertex. And we know that the h value is the x value. It controls shift left and right. And we know that the y value, or the k value, matches to the y value, and that controls movement up and down. So just looking at our function, x plus 4, we know that we're going to have a base function and that it's going to move left and right and up and down. Okay. All right. So let's look at our parent function. Please ignore my dog. So our parent function is y equals x squared. And from this, we know that our graph is going to look like this, and that it's going to have a vertex at 0, 0. Okay, so if we're not sure how to graph our parent function, we can use a t-chart. So we can say when x equals 0, then y would also equal 0, because 0 squared is 0. Okay, and we always want to know what goes on around the origin. So we would pick 1, -1, 2, and -2. Okay, so 1 squared is 1, -1 squared is also 1, 2 squared is 4, and -2 squared is 4. So I'm going to add another column to this, and that means that our points are going to look like this. So we're going to have point 0, 0, point 1, 1, point -1, 1, point 2, 4, and -2, 4. All right, so now we're just going to graph these points and connect them, and we'll have graphed the first stage of this function. So we have the point 0, 0, we have the point 1, 1, we have the point -1, 1, then we have the point 2, 4, and we have the point -2, 4. So our graph, wow, that was really bad. Our graph is going to look like this, which does look like we said it would. Okay, so let's talk about how to write what we just did. Okay, we used y equals x squared as our parent function. We chose values for x and calculated values for y. and calculate it. Then graphed each point and connected them. Okay, if I'm writing incomplete sentences, I should put the word "and." Okay, so that's our first stage. Let's look at our second stage. We said that our H's are controlled our X values, so that was the X value of our vertex. And we have a +4, but our basic form has a -4. Or has a minus, so that means that our H value is going to be -4. So for our second phase, we're going to say y is equal to x, our minus, and then we would have to put -4 squared. Okay. And actually, I would need parentheses right there. And then out here, we don't have a k value yet, so it would just be 0. Okay, well, think about this -4 means that we're going to shift everything to the left. So the only thing that we changed here was we took our x values and we subtracted 4. So if we start with our x points from before, right? So if I just recopy all of this, I have 0, 0, 1, 1, -1, 1, 2, 4, and -2, 4. Okay, we're shifting our x value. So we're going to move it 4. So that means that we're going to subtract 4 from every x value, and we're going to keep our y value the same. All right, so I'm going to subtract 4 from every x value and then keep my y value the same. 0 minus 4 is -4, and I keep my y value at 0. 1 minus 4 is -3. Keep my y value the same. -1 minus 4 is -5. Keep my keep my y value. 2 minus 4 is -2. Keep my y value at 4, and -2 minus 4 is -6. And I keep my y value the same. So what I did was I shifted this whole graph, should shift to the left 4. So let's graph these points and see. So I have -4, 0, -3, 1, -5, 1, -2, 4, and then -6, 4. It's probably a little wide. If I connect them, then my whole graph shifts to the left. So if I wanted to write that as a sentence, I could say we subtracted 4 from each x value, which shifted the graph 4 units to the left. Okay, the last part, to make our functions match up here, we have to add 1. We know that that 1 corresponds to the k, which is the y value of the vertex. So we're going to change the y value. So we have now y is equal to x plus 4, that's what we just did, plus 1. So that means that our we're going to use the same points that we finished with before. So we have the points x and y, right? So we have -4, 0, -3, 1, -2, -5, 1, -2, 4, and -6, 4. Okay, and now what we're going to do, we're going to keep the x the same because we haven't changed that, but we're going to add 1 to the y. Okay, so we're going to say -4 and 0 plus 1 is 1. -3 and 1 plus 1 is 2. -5 and 1 plus 1 is 2. -2 and 4 plus 1 is 5. -6 and 4 plus 1 is 5. All right, so now I just need to graph these points. So I have -4 and 1, -3 and 2, -5 and 2, -2 and 5, and then -6 and 5. So our new graph looks like this. Okay. And so what did we do to write the sentence? We added 1. I should write that out. We added 1 to each y value, which shifted the graph up 1 unit. Okay, so let's just check. If we go back and we look at our original function, we said we're going to use the parent function of x squared, that it should look like this, which it did. And then we know that this would shift to the left 4 and up 1. So did our parent function shift to the left 4 and up 1? So it did. Our answer is reasonable. So we're finished. Good job.